I've always enjoyed getting to meet people in this line of work, be it clients around town, clients across the country, musicians across the world, and, in the past couple of years, other people in this crazy guitar YouTube world. And not the only one, certainly, don't want to leave anyone out, but one of the people I've really enjoyed getting to know a little bit is Keith Williams from 5 Watt World. And I really enjoy our phone calls, though we each have to be careful because they can just go on for an hour before we realize it. But anyway, he's been a joy to get to know as much as I've gotten to know him. And I look forward to our chats, and I love his channel. And he reached out to me about this old Gibson GA-40 build that he did, certainly more than 12 years ago. And he wanted to know if I would be interested in going through it and calling him out on any mistakes he made and just make it really great and really bulletproof. Now, I said I'd be glad to, but I don't want to hurt your feelings. While I won't be judging this the way I would be doing a commercial build, this is his personal build, not for sale. I still have already found things that could be done better, and I didn't want to burn any bridges with him. Now, Keith has got a great sense of humor about himself and a real sense of perspective at what he's good at and what he's not good at. There are things that he loves doing he would not call himself an expert in. So this is a kind but firm remonstrance. If you watch this and you think, my God, he's just savaging the guy. I'm not. This is literally what he asked for. This kind of input is what he's asked me to do because he wants to know, because he wants to build other amps in the future maybe. And, what mistakes did he make that he did not even know he was making at the time? So let's go through this. First, a little bit of an elephant in the room. I've got some blue tape here and on the back. This amp was made using the chassis and a faceplate by a guy that both Keith and I know, who has since retired, who had an amp company. And underneath this blue tape is that logo, though this was never made by or sold by that company. And because I'm going to call into question some of the construction techniques found here, I just didn't want anyone to think that it was the company whose name shall not be mentioned, because it's not. He was just kind enough to let Keith use this chassis, which is a very good Princeton-sized chassis made of steel. It's a really nice thing with welded sides. So just to take that out of the equation, the blue tape is going to be mysterious. There's another little bit on the back. But everything that I'm critiquing is Keith's work. I'm just going to treat this like it's any amp that comes in, with the caveat that I won't be as savage towards any faults as I would be if this were a commercial build by someone who's supposed to be doing this professionally. I always like to check first and see if things are tight. So let's first do the finger test on the hardware. Up. Input jacks are both loose to the fingers. These should always be at least tight enough that you cannot possibly undo it with your fingers. Let's see. Let me get the knobs off and see what we see underneath the knobs. If these are loose, are these loose? Several of the knobs have these pretty significant cracks in them. Some just bear little whispers of a crack. Others are fairly well developed. I'll ask Keith if he wants me to replace all the knobs with some more chicken heads or if he wants to do that himself, but something to be aware of. Over time, and looks like Dacoware, looks like the good stuff, but plastic ages with exposure to ozone and stuff, and the force of a set screw in this plastic going against this brass will not ever move or change, but the plastic does. It shrinks as it ages, and that's how you get these cracks. So that's optional, but recommended. Turning our attention to the pots, we have at least 3 different kinds. These 3 are 8mm alphas with the pot metal bushings. Let's see if they're tight. No, I can loosen that by hand. That one's tight. That one's loose enough to turn by hand. These 2 are alpha 3/8" bushings, which are much better quality, and they are tight. This one, I'm not sure what this is. I'll check from the back. It might be a 3/8" bushing alpha with a different nut, a non-original nut. This nut's very shiny, as is this input jack nut here. These are both Switchcraft jacks. I've already peeked. This is a Switchcraft nut. This is not. This one's shinier and more domed. It's not original. I'm going to put in a Switchcraft nut so they match, because it's nice when things match, but also I trust the metal on the Switchcraft nut for something as important as an input jack. Whoo boy, I see something in the rear. This IEC connector is held in place by machine screws. Looks like number 4s. Might be metric, but it looks like a number 4. Without nuts. Now, a machine screw does not inherently grab onto a steel chassis like this. It's probably wedged in place and may have lasted all these decades, but that's not good. I'm going to find what size that is and put either a cups or a nylock nut on each machine screw. Make the power connection rock solid. And I'm going to clean up these solder joints. That one in particular is not very good, and that is one of the primary connections to the power transformer. The other one is going off to the fuse and switch. More on that in a moment. You can see that the IEC connector's ground is made with this green with a yellow stripe, very heavy gauge wire going directly to chassis. That part's good. Now, if this were a commercial build, I would ding it because it is going to one of the bolts used to mount the transformer. And that is not electrical safety code. If this were a commercial amp, it would need to have its own screw to chassis connected to it with nothing else shared with that joint, so nothing can strain this. Since it's his personal amp, I'm going to let it slide. I will disconnect this. I will clean all the surfaces and then retighten it and make sure it's really, really tight. On an amp which has essentially a Princeton reverb size power transformer, it's less of a concern because the weight's not that great. But from a deluxe reverb transformer on up, the weight of the transformer over time can actually make the steel chassis flex. And as it flexes and bends, all these nuts can come loose. And if those nuts are being used for ground, not just to mount the transformer, you can have big problems. I've seen this over and over again. For this one, like I said, it's Princeton. I'll just make sure they're all really tight and that ground transformer bolt is really clean underneath all that. Here you can see that they have the choke mounted over the hole that would be there for the filter caps. And if this were a Princeton build, that's fine. I'll just make sure that they're tight. Here you can see the unused primary connections on the transformer are properly taped off, and he has got this nylon wire holder beneath the nut, which is holding this part of the transformer in place. That's actually not good. Not only has the nylon deformed as a result, but it's going to compromise the strength of this connection at this corner of the power transformer, because this cannot be as tight against the metal because the nylon's there and the nylon compresses and dries out over time. So what I'm going to do is I'm going to remove this nut, slide this up, put the nut back in place right up against the chassis, and then I'll put that on top of the Kep's nut with a standard nut just to hold it in place, and then a dab of Loctite. This is a fine solution just to hold any unused wires, but it's compromising the mounting strength and reliability for the transformer. This is not really necessary. You can just have these taped away or curled around themselves, but it's not a bad touch. It just needs to be done in a way that does not compromise the physical integrity and strength of the mounting hardware. And again, if it seems like I'm being mean, this is literally what he asked me to do. And it's the kind of feedback I'll give to anyone. But if it's an owner, I'll give it in a nice spirit. If it's a commercial amp that's built like this, I've got problems. So this black wire coming here is from the IEC connector. And this is the hot coming from the wall. And it is going to the sleeve connection on the fuse holder. It should be going to the tip connection on the fuse holder, so that when you're changing a fuse, if you forget and don't unplug the amp, you're much less likely to electrocute yourself. The code is the hot goes to the tip of the fuse holder, and the sleeve of the fuse holder then goes to a power switch. They've got it Keith's got reversed. Uh-oh, what's that? All right, the fuse holder is loose. Is it just physically broken? It looks like one of the flimsy plastic ones. Is the nut actually loose as well? Yeah, the nut is so loose I can turn it with this plastic pointer. And that plastic on this kind of fuse holder, a lot of times once it gets a little bit loose and it wiggles, it will shatter. So I'll replace that fuse holder. I can tell this is one of the cheaper ones. It's got a really, really shiny nut on it. The good ones tend to have either a very matte silver nut or a matte brass nut. This is a fairly cheap one. This is a good quality switch. Is it a Carling? Yeah, it's a good quality Carling switch. This is the one used that gives you off standby power. It's wired a little bit incorrectly as far as that hot goes. The rest of it seems okay. It's got some really sloppy solder joints down there that I can't really show you at the moment. I'll redo that. No offense, Keith. That's some sloppy work down there. I mean, it's worked all this time. You've gotten away with it, and it's loose. It's physically loose in the chassis. That's really not good for a power switch. Let's take a look at the rear of the amp for a moment. All right, the other side of the fuse holder, which is loose. Let's see what fuse he's got in here if I can take it out. All right, it's a 2 1/4 amp. That's a tricky one to find these days. I'm sure a 2, which is the more common value, is going to be just fine. Yeah, this feels like one of the cheaper fuse holders out there. I put it back in place just to keep it out. I'll just move it out of the amp for right now. Because it's loose, it's hard to put back in place. The power switch being loose, oh yeah, I can turn that with my nail. And not only is it loose, when it comes to power switches like this, and with this 3-position on standby off switch that Carling sells, it comes only in a long bat form. In general, for a Fender style amp, I prefer to use a short bat switch, because the bat is the length of this part that you actually move, because it'll stick out less from the cabinet. So when you're moving the amp around, you put it face up in your car, and it slides around on your way to the gig. This little bit of metal isn't sticking out past the lip of the cabinet and shearing off or getting dinged up. So what I'll do is I'll put another nut on the inside, and I'll flush mount it. And you can get it really, really close, like they did on the old Fenders. So it'll stick out quite a bit less. Same for this bridge switch, which is a way that if you plug into just the one input on the front, you can go into both channels at once. It's also loose, totally loose. And this is another big Carling switch, totally overkill for switching between 2 channels, but there you go. It'll work just fine, but when I put it back together, it'll be flush mounted to the chassis like that and really tight. Almost cosmetic, but it bugs me. The speaker jack and the foot switch jack are also protruding a lot from the chassis. That's because he's used long bushing switchcraft jacks. I don't know yet if they have a tooth washer or not. If you use the standard length jack, this won't stick out as much. If you have the long bushing, you can just put 2 or 3 tooth washers and get it closer to flush. I'll see if I have the proper jacks on hand. I'll just trade you out a long bushing for a short. It's pretty simple to do, but it's all these little things that add up. And on that note, you've got a missing hole plug. I've got these 3/8" hole plugs that will match. I'll plug that up for you. What this is a standard Princeton style chassis. So you would have had speakers, and then you would have had vibrato, then you would have had send return on the reverb. And then there's this extra hole here, and this extra hole is plugged here that's used on the Fender that's not used on these. But, it's overall a really good way to repurpose the chassis out of a Princeton. Right here, it's a little bit hard to show because you can get your eye closer to something than you can get a camera lens. The lens is right now zoomed in. It's about 6 inches long, and it's a certain size. And, I don't have a macro thing or anything to get too much closer than what it is now. I'm zooming in post to help, but there's a pretty squirrely connection right here on this terminal strip. And this terminal strip is taking the heater filament secondaries from the power transformer to here, then they break out, and then they go to the octals. I don't know why they just didn't run it straight to the octals, but here it is. So I need to clean this up and make it reliable. You don't want to have a heater connection go out. This green and yellow striped wire coming from the power transformer going over here to the cathode of this octal socket. This is the heater center tap. I'm going to remove this from the cathode, tape it off with those other unused wires, and we'll put in some heater balance resistors, some 100 ohm half watts, probably over here. Maybe I'll figure it out, but referencing to the cathode makes sense in a cathode bias stamp because it's going to give you better hum rejection than going to ground. But the physical center tap can fail if you have a short in an output tube. You can burn up this wire and toast your transformer in like a nanosecond before a mains fuse can trip. So best practice is to avoid physical center taps when possible. I'll be neatening up some solder joints that are crucial, like the ones here on this output jack. And here you can see a pretty good length of heater wire where the insulation stripped back and there's a bare wire exposed, and it could touch the thing next to it, and little snippets of wire could touch other things. Same kind of thing over here. Just little things like that to clean up. Overall, though, the connections aren't bad. I just want to make sure that they're as close to bulletproof as possible. Here we have the HT center tap wire going to chassis right here, and this black wire is the ground for everything else. Now, the HT center tap ground and the reservoir ground are the noisiest grounds in the entire amp, and they can either run directly to chassis by the power transformer like you find on a Fender, or they can run with a separate wire from everything else to a ground connection at the input jack. But when they are joined to everything else and then everything runs to chassis ground together, you can have a problem. This may or may not be an issue here, but I'm going to change it again for best practice because it's easily done. And that's simply a matter of disconnecting this ground from all these other grounds and running this black wire to here, or probably a new wire, a little bit neater, but just having the reservoir cap go to ground there and have everything else go to ground right by the input jack. Not only is some physical separation between the two good because the chassis actually has a few fractions of an ohm of resistance, which gives you more isolation from the noisy stuff to the clean stuff, but having the circuit ground for everything else made as close as possible to the input jack really helps with the chassis behavior to shield against radio frequencies and everything else, all kinds of noise from the outside. It's a much better shield if the ground is right there at the input. See Merlin Blenco's articles on valvewizard.co.uk for more on that. As to the rest of it, it's a pretty good quality GA-40 replica. It is the circuit of a Gibson GA-40. It is certainly better built than the old Gibsons, which were kind of a travesty as far as the layout, some of the components used, and the copious amounts of brown glue that becomes conductive. So this is a good thing. It's got some generic caps here on the cathodes. Not necessarily a bad thing, but I think it's about time to recap it. This amp was last updated in 2012, so I've not asked Keith how old it really is, but it's certainly more than 12 years old, and capacitors are inexpensive. So we'll get some new 10 microfarads, a new, 22 microfarad, and then the cathode bypass caps will get some Vichys in there, just so starting in 2024, everyone will know that, hey, that's rock solid. These look like older Nishikans, which were fantastic caps, but again, they've not been made in a long time, and these have got to be at least 12 years old at this point. Typical lifespan that you expect is 15 to 20 years. While it's here, let's do some preemptive stuff. The wiring is good. It's not the neatest in some places. Other places, it's fantastic. I think overall, Keith did a good job. It's all solid core, and the insulation hasn't melted everywhere. A couple of little places, a couple little snips of excess that don't really affect anything. We'll deal with that as we need to. I don't know if any of the old carbon compositors are noisy or not. We'll find out when we power it on. He used these two black beauties here. Hopefully they're fine. They may or may not be. Black beauties are very, very old caps from the 50s and 60s. And if they leak, I'll change them out. If they don't leak, they can stay there. Same for this blue molded cap here. But that's a good one from the early 70s, looks like. And those are usually just fine. And the orange drops should be just fine. And these little, I think these are Zycons, should be absolutely fine. Not a lot to go wrong here. I'll make sure that all the connections are good and that nothing is microphonic. When you have relatively stiff solid core wire like this, you can get vibrations and microphonics. Hopefully that's not an issue. Like I said, it's these two alphas and this one are the 8mm, which aren't as good quality in a lot of ways as the 3/8. So I'll see what the values are, and higher quality ones are like $1.50 each. So it's no problem to do that. And I'll make sure that they're all securely mounted. The master volume was a later addition to the amp. It is a simple cross line. It is not Keith's favorite, so I'm going to see what other options I can give him without reinventing the entire wheel. I think the GA-40 has got a paraphase phase inverter, so I need to be careful. A cross line can work. It may just be the wrong taper or the wrong value. I will find out through experimentation. Should be a fairly simple thing to fix either way. The input jacks. The input jacks are switchcrafts. They're isolated from the chassis with those isolation washers, and due to the acrylic faceplate providing the shield from the other isolation from the other side, the ground is made with these wires going here to the cathode. That's fine. Not a very good solder joint right here. I'll be cleaning that up as I go. And again, Keith asked me to be this critical. He wants this thing to be really great. During the process of doing the work that I know needs to be done, I might find some other things, and always keeping an eye out. All right, yep. The nut here, one of the two bolts that hold the output transformer in place, that nut's totally loose. So it's not a Kep's nut, it's just a regular nut. That'll get replaced with a Kep's nut and made real tight to everything. And when I change the grounds here, it means I have to take all the pots out and the jacks out and lift the board up. I'll do an inspection of the underneath, make sure we don't have any globs of solder anywhere. Eyelet boards like this can be tricky in a build like this because there's no backer to them. If you have an eyelet board mounted on traditional fiber board like an Offender, there's another one right beneath it. So any little drips of solder get caught. Things like this, you can actually get solder stalactites which drip down and occasionally will even touch the chassis, and bad things can happen. I'm not saying Keith did that. I'm saying that's something that I look out for when I find a board like this, which is a really nice FR4 fiberglass board mounted with a big air gap beneath it, but it's eyelet rather than turret because I know things can drip down. I just want to be sure of all that. Overall, though, I'm very optimistic about this. I think this thing should sound fantastic when I'm done. It might sound pretty good now, but given how loose all the hardware is, it probably has not been sounding its best for a while now. So Keith, I hope you're still talking to me after seeing this video. I hope you don't feel that I went above and beyond in my duty to reprimand you. It's all meant with love, everything with love, brother. And I hope that you guys find this interesting and stay tuned to see the transmogrification. Thanks for watching.